When you are adding mixed numbers with unlike denominators, there are going to be several steps that you need to go through. So the first thing that I'm going to do is demonstrate this by building it with the fraction pieces, and then we'll go over it again, showing how we can write this down. So the first thing I'm going to do is build the 1 and 5/8. So 1 and 5/8, I have 1, and then 1, 2, 3, 4, 5 eighths. The next number that I am adding together here is 7 and 1/2. So I have 1, 2, 3, 4, 5, 6, 7, and 1/2. Now that I have built these, the problem here is that I have two different denominators. These are two different kinds of fractions, and I want to have equivalents. So when I look at this, I see, oh, I'm working with eighths and a half. Well, I know that the equivalent fraction to this is simply 4/8. So if I exchange this and I end up with 4/8, I know that I will now have everybody in the eighths format. So 5/8 plus 4/8, let's see what I get. So I'm exchanging that one out of the way, and something interesting is going to happen here. I actually have 9/8, which means I have enough to do another exchange and get 1 whole. So I still have this 1/8 hanging out here, and now I'm going to exchange that for 1 whole. And when I gather everything together, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. So my final answer is going to be 9 and 1/8. And then when I flip it over, I can see, fantastic, I did it correctly. It is 9 and 1/8. Now, what I did here is something that I can write down. So when I had 1 and 5/8 plus 7 and 1/2, one of the things that I would recommend is actually turning this into an improper fraction. I enjoy working with improper fractions because then I only have one thing instead of 2 on each side to add. Now, I wouldn't have to do that. I could start with just 1 and 5/8, and then I see that 7 and 1/2. Oh, I know a very easy equivalent. I keep the 1 and 5/8. I didn't change anything there, but I will rewrite it to keep it even and neat. 7 and 1/2. I know that if I multiply this by 4, top and bottom, I will get 7 and 4/8. So I have found my equivalent fractions. Now when I add these together, 4 plus 5, I'm going to end up with 9/8. I can add this, but I'm going to find that I need to do some work here because 8 and 9/8 is not going to be a proper way to write a fraction because this is improper, plus I've got a whole number here. So I'm going to need to take out my 8/8. So I'm just going to subtract 8/8. See that I have 1, oops, sorry, that's tiny. I'm going to have 1/8 left over, carry it over and add it here. I will end up with 9 and 1/8, which, if you'll recall, was the correct answer. We are going to work on subtracting a mixed number set, and here I'm going to work it out again with the fraction pieces first. So I'm going to build 1, 2, 3, and 3/4. 1, 2, 3. Now, there's a couple different ways that I can do this with the material, but the way that I'm going to show you today is how I take the 2 and 1/8 out of this to see what is left over. Now, the first thing that I'm going to have to do here is convert so that I have like denominators. I know that fourths and eighths are a pretty friendly set. All I have to do is multiply this by 2 on each side, and I will end up with 6 eighths. So 6 eighths is going to be an equivalent of 3/4. I can see here that each one of them is going to be cut in half and give me eighths. So now instead of 3/4, I have 6 eighths. So I am just going to do a quick exchange there. And the first thing I need to do is build this number starting in the smallest place value, which is the fraction. So I'm going to pull over 1/8. This here is what's left over as the difference. I then need to pull 2 over. So I'm going to pull over 2, and I should see this is my subtrahend here, and I have this difference left over. And my difference, in fact, is 1 and 5/8. When I flip this over, I will see that that is, in fact, correct. So 1 and 5/8. I am now going to check my answer by using paper. So on this one, I am going to convert this into an improper fraction. So I have 3 and 3/4 minus 2 and 1/8. And the first thing that I'm going to do is convert these into improper fractions. Because I'm doing it with improper fractions, that will mean that instead of having two different kinds of things, both whole numbers and fraction pieces, I'll just be dealing with a whole lot of pieces. So 4 times 3 is 12, plus the 3 left over. So I have 12, 13, 14, 15 fourths. And I'm trying to take away 8 times 2 is 16, plus 1 is 17 eighths. So now I have 15 fourths minus 17 eighths. But this isn't going to work because these are unlike denominators. So in order to make an equivalent, all I have to do is multiply the top number by a factor of 2. 15 times 2 is 30, 4 times 2 is 8, and then I'm going to take away the 17 eighths. So here I have my rewritten problem. I have 30 eighths minus 17 eighths. And I can do that over on the side here, 30 minus 17. And I'm going to end up borrowing, carrying over so that I have a 3. 2 minus 1 is 1, and I should end up with 13 eighths. Now, if you do it this way, you are going to want to either leave it as an improper fraction, or I can go back to my mixed number. In order to figure that out, I simply divide it out. 13 eighths means 13 divided by 8. Now, 8 isn't going to go into 13 very many times, right? It's only going to go in there once. I will use up 8, which means I will have 5 out of the 8 that I needed left over. So the reason I always have you do your division remainders in fraction form is so that it will be helpful when you're working with fractions. So again, I ended up with 1 and 5/8, and that is exactly what my card says. Now the hard part to remember here is that if you do not have enough, if you need to regroup, you are going to have to remember that you're not just carrying over a 10. So for example, 1 and 1/3 minus 2/3. Now, when I am doing this, it is tempting to say, oh, mark that out, carry over a 10, I get 11/3. No, no, no. That only works if I am using tenths, but I am not in tenths, I am in thirds. So let's build this out to see. 1 and 1/3, and I need to take away 2/3. but I don't have enough. When I break this whole number up, I don't take over 10 tenths because that's not helpful. I'm not using tenths. Instead, I'm going to bring over 3/3 because that is how many thirds I get out of one whole. Now I have 1, 2, 3, 4 thirds. So when I take this over, I am actually going to add to it 3/3. I now have 4/3, and I need to subtract 2/3. What am I going to have? I take away the 2/3, and what do I have left? Oh, that's nice, 2/3. So the answer to this problem definitely depends on me remembering that when I borrow, I am going to get an equivalent to whatever that denominator is. It won't be 10 unless you're doing, I'm writing upside down, unless you're doing 10 tenths. But I'm not doing tenths, so 3/3. So be very careful with the regrouping and ungrouping when you are working with fractions and mixed